Hi, this is Kristen Dykstra, and I teach high school geometry. This week, our task was to choose a problem of practice and illustrate how a digital tool would address the problem. My problem of practice is classifying and proving quadrilaterals. I believe this is an ill-structured problem because there are several important variables that need to be considered in context at the same time. For example, students must explore visual, property-based, and relational characteristics of quadrilaterals according to their side lengths, angle measures, and lines of symmetry, in order to write a geometric proof using congruent triangles. That is, students must make connections to prior learning and use reasoning skills to formalize definitions, make conjectures, and write proofs. In order to master this skill, students must explore the 7 basic quadrilaterals, create comprehensive list of properties for each quadrilateral, categorize each quadrilateral according to its characteristics, and write a geometric proof of a given quadrilateral. To address this problem, I will use GeoGebra. GeoGebra is an interactive math software program that allows users to manipulate and explore geometric shapes or algebraic theorems. This task also allows users to test out their conjectures by dragging the vertices and morphing and resizing figures. Naturally, students begin to reason, and through discussion and exploration with the shapemakers, they are able to formalize definitions. Even though each shape may be manipulated, each maker is created so that the defining properties of each shape are preserved. So for example, the square shapemaker will only allow the user to make the square shape. This is an instant correctness check for students to continue on with their exploration. This task also allows students to identify properties such as sides that are congruent, angle measures that are the same, and it allows them to stretch and pull each shape in a way that might be different than the traditional textbook figure. The level of mathematics that can be explored using this technology is much higher than if using pencil and paper. It's much harder to think about the properties of trapezoids when you can only explore a finite number of examples versus an infinite number of possible trapezoids that can be seen with the help of the shapemaker. The teacher has many options with GeoGebra. As you can see, the shape that I made has the measurements and has the diagonals constructed. There are makers that you can find on GeoGebra Tube that are already constructed that do not have the diagonals and would make the students have to construct them on their own. GeoGebra works well in math classes because it allows students to morph and manipulate geometric objects or algebraic functions. With a textbook, students are limited to 1 or 2 visuals of each shape. Textbooks also do not allow them to see the relationship between sides and angles when a shape is morphed. Students are actually able to test their conjectures and formalize their definitions based on their findings, rather than read the theorem straight from the text. One of the best features of GeoGebra is that the software is free. Students can download and use the program on any device that has Java.